All right, well, good afternoon, everybody. Here we're going to do a little econ today. We'll start by talking about Pornhub. What?
You're gonna have a good follow-up to this.
It's on your browser.
So Dr. Ruther is visiting Ball State today, and he is presenting research to the economics department this afternoon related to Pornhub and the value of Bitcoin. And the story goes that a little while back, a bunch of people said that really horrible things were happening on Pornhub, and as a result, the major credit card companies decided to stop making payments to Pornhub. And as a result, the question is, well, how are you going to pay if you can't use your credit card? And the answer is, we'll use Bitcoin. So what Dr. Luther does is he shows how the value of Bitcoin left up. When they had to switch to Bitcoin, I did not even do that. So the value increased dramatically when this happened. So now one of the things that Dr. Luther says in this paper is that that payments industries are network industries and deal with network effects. And so we're going to deal with network effects maybe at the end of the day today. Maybe we'll get to it on Wednesday. I just thought that was kind of interesting. It's a short little paper that he does here, and I'm going to be interested in hearing him present on this material this afternoon at the economics workshop. Okay. So there you have a little interesting stuff. Okay, does anybody have my, well, before I get into that, here's week 7 on Canvas. It basically says read chapter 6 of Karl Perloff. We might go over the exam. If we get a chance, I'm going to try to actually get started though on the Cournot model today of oligopoly. But we also have antitrust watching. And for that, we have Anna here. Anna? No. Okay, is Kenny here? How are you? Good. Okay, so you have this article. Apple finds itself under scrutiny in Washington big tech clampdown. Will it load? Will you be able to read this? Okay. Here you go. So, where'd you find this, and what's interesting about it?
So I found this on the Wall Street Journal, and it's pretty much that the government doesn't like how Apple's App Store is currently run, because right now Apple pretty much gets to choose what is on their App Store, and if you want to be on their App Store, you have to go through their in-app payment system, which as they feel kind of makes it a monopoly that not everyone is free to put whatever apps on their iPhone if Apple doesn't agree to it. So they want to run a bill that would make it so app developers could sidestep Apple and not need their permission to create apps on there for their phones and not have to go through their in-app payment system. And Apple doesn't want to do this. And their big reason is that there could be privacy issues with people being able to get into the phones that are from unauthorized apps.
Okay. Anybody else hear anything about this in the past? You been aware of this situation? There's a big gaming company in particular that was interested. I don't know if it was Fortnite or some other game that was it Fortnite?
Yeah, it was Fortnite. They were trying to do their in-app purchases to go straight towards them instead of Apple.
Right. So the thing about Fortnite is that that
you spend a lot of money buying I'm calling it garbage. Like Gustavus non-especutant. Buying things, like skins or extra amenities for your character on the game. And you have to pay for them, through, if you're playing on an Apple device, you have to pay them through the app system. And Apple takes a big cut of that. And Fortnite was like, hey, that's my money. And so there's a big debate about that. And now, generally speaking, most apps are small enough and the revenues are small enough that they're not going to make a big beef about this. But Fortnite was big enough that they could sort of start pushing this around. Now, here's the thing, right? Is Apple a monopoly? Or is Apple behaving anti-competitively? Apple's offering a particular user experience, right? Whether Fortnite should be allowed to get a bigger share of the cut or not, that's interesting. What could Fortnite do to pressure Apple?
Take it off.
Take it off the platform, right? Okay. Then Fortnite's also giving up a lot of money though. So it's a complicated thing. There's a lot of contention between the two. In my experience, working with similar situations, the way I like to talk about this is to say this. Yeah, I need to share that. Where's my zooms? I'm already in a Zoom. Here. I'm writing a short little paper called On Sub-Wordling. You guys play Wordle?
Yes.
No. Yes, okay. So the idea of sub-wordling is this, that it's considered gauche, right, or rude to I won't let me share. Share screen, change the rules. That's what it. Everybody
Twitter all the time, but I don't know.
So what's the one rule of Wordle? Don't share the answer, right?
Answer what?
To the puzzle for the day. You don't share the answer.
Did you get multiple words out of that?
No, you only get one a day. The whole world only gets one a day.
That's a word.
So you only get one Wordle a day. Now, the trick is, can you share your solution with other people? Sure you could, but that takes the fun away from them, right? So the first rule of Wordle is you don't share the answer. But what if you and a friend, right, have similar interests, right? And you sort of give a hint to the answer to Wordle, but only your friends will get it, and they know that it's kind of a joke. They might be a little bit upset with you for sharing the hint, but at the same time, you've communicated something else with your friends, haven't you? You communicated that we share certain affections and certain interests. So you've demonstrated some approbation towards one another. Now the puzzle is whether that sense of approbation is sufficiently large to overwhelm how pissed off your friend is that you shared a hint. So this all came to light because the other day the word was tacit, T-A-C-I-T. And I can share it, it doesn't matter. The word was tacit, right? And my post said, Michael Polanyi really liked today's Wordle. Right? Michael Polanyi was a chemist and then a philosopher of science, but also sort of an economist in some ways. And he wrote all about tacit knowledge, things that we know but we can't really articulate. We can't articulate particularly well, right? And so I made this hint about Michael Polanyi, and a friend of mine who knew who Michael Polanyi was, got the Wordle in one guess, and he was mad at me. But not really. He was a little bit mad, but not really. Former student, actually. And so we got to talking about it. I was like, well, it only counts because you know who I'm talking about, and we've got this sort of inside connection. I'm sorry for sub-wordling you. right? And he says, you should definitely write an essay called On Subwordling. And so I invited him to co-author it with me. I think it would be a kick if we were able to get it in the New York Times, you know, since they now own Wordle. That's my goal for the next 2 weeks, or get that done. Why was I talking about that? Oh, because of social groups, okay. And that's what I end up talking about all the time. I've had a chance to grade a couple of exams, not all of them. I've looked at a few more of the others, and you guys struggled. And that's okay, there will be a curve on the exam. I was concerned heading in, because I was like, oh, this is all just review. This is stuff that they all learned in intro micro and intermediate micro, but I'm always reminded, you know, it helps to have a reminder and to review this stuff. And maybe actually feel good about things because I've been worried that I've just been talking about things that are pure review for most of you, but it turns out, yeah, it's review, but you need to hear it again. And so that's okay. So I'm actually feeling better after the exam than before, even though you did that. Because I hate you? No, okay. because I feel like I'm doing you actually a service in what I'm doing. Chapter 6 gets into discussion of oligopoly. All right, and so we go from along the spectrum of having pure competition to having one monopoly, single monopoly, right? And then we have, you know, two firms, and that's called a duopoly. And then a small number of firms is called an oligopoly. Right? And then there's this spectrum. Along here we have something called monopolistic competition. And so most of the time we're operating in this realm of monopolistic competition. Occasionally we run up against situations of monopoly, and a duopoly is really a special case of monopoly. Now, what about cartels? Well, cartels are sort of oligopolistic circumstances that find a way to behave like a monopolist. If they manage to discover a way to become monopolies and behave like monopolists. Now, what I want to do is walk through some algebra here to try to understand how to compare the outcomes in terms of quantity of output and welfare to the consumer, in terms of expressed simply as price, of different market structures. Okay. And in order to do that, we're going to build a simple model of a market, and we're going to say, okay, we've got a demand curve, and we're going to give this an algebraic expression. We're going to say that price is equal to A minus BQ. How would you interpret that expression?
Like a slope intercept form?
Slope intercept, y equals mx plus b, right? Okay, so I've got the b first here in that expression. I've got the intercept is A. So up here we've got A, right? That's where this line intercepts this curve, this axis. Okay, and then the slope would be negative b. Okay, so it's a downward sloping demand curve, thank God. Okay. Now, what would be the monopoly? So, well, let's start with that, and then we'll say, okay, so we've got this expression for demand. What expression can we give to cost? Because there's almost always costs involved, right? Or an idea of supply. For a monopolist, their marginal cost curve is similar to their supply curve. Okay. So let's give cost an algebraic expression as well. We'll say that cost is some constant plus a marginal cost times quantity. So we have an intercept, okay, right, and then we've got a slope, C, and that is a that's related to quantity. As quantity increases, we multiply it by our slope and we move up. Straightforward. Okay, well then, where would the perfectly competitive firm produce? They would produce where supply equals demand, right? Okay, so we could set this equal to this, and we would find a perfectly competitive outcome. I leave that as an exercise for the student. Okay, but what I want to get to is the monopolistic result. So if we've got a monopoly and there's a demand function that is price equals A minus BQ, and the function for cost is K plus CQ. Okay, what do we want to do? We want to solve not for the perfectly competitive outcome, but for the monopolistic outcome. Right? Okay, and what do we want? How do we want to solve for that? Well, we'll solve for quantity. That's the first thing. And from quantity, we can figure out price. So we're going to need marginal revenue, an expression for marginal revenue. And some of you will remember you can do that simply by doubling the slope since it's a linear demand curve. So marginal revenue would be equal to A minus 2BQ. Do I need to remind us? Like, it doesn't hurt, right? Why is that true? Well, we've got an expression for demand. What about a total revenue? Total revenue is price times quantity. And we have an expression for a price in terms of quantity. So P equals A minus BQ. So I can put A minus BQ in here for P and then multiply that by Q. So total revenue is AQ minus BQ squared. And taking the first derivative of total revenue with respect to quantity, I get A minus 2BQ. So there's my expression for marginal revenue. I've done this before, but it's helpful to go through it again. Well, now I want to find what quantity the monopolist would produce. So I set marginal revenue equal to marginal cost. What would marginal cost be? Well, it would be the first derivative of the cost curve with respect to quantity. And so I take the first derivative of this with respect to quantity, and the answer is simply what? C. Because K is a constant, so it drops out. And so the first derivative would just be C. So marginal cost is C. Okay, so then to find where marginal revenue equals marginal cost, I get A minus 2BQ equals C. And to solve for quantity, I move everything around and get just Q all by itself. So I got negative 2BQ equals C minus A. To flip the sign, I get 2BQ equals A minus C. I get Q by itself, I get A minus C over 2B. And this is the monopoly quantity. We get to the same result by searching for the profit maximizing solution. So we can start with profit equals total revenue minus total cost. The profit equals, when we go back to the total revenue equation, which is A minus BQ multiplied by Q minus K minus CQ. And I'm just plugging in total revenue and total cost functions here. Remember to distribute the negative sign.
And then I can expand this and I get AQ minus BQ squared minus K minus CQ. And I can take the first derivative of this with respect to quantity. And I will get what? I get A minus 2BQ minus C. And profit is maximized where the first derivative is equal to 0. And so I can solve this all for Q, and long story short, we get the same thing. Q equals A minus C over 2B. So that's this point. A minus C over 2B. Yes.
Where did the K go when you took the derivative?
When you take the first derivative, since it's not attached to a quantity, it's a constant, and the slope of a constant is 0. Fair question. And sometimes I'm surprised that I'm actually able to articulate those things sort of mathy, in a mathy way. Somewhat accurately, because I'm not super mathy. But there you go. Can we make our lives easier? Yes, please. No. All right. Let's assume that marginal cost equals 0. And what have we been doing? We've been including some sort of a cost. And here we have an upward sloping cost. We can have a flat cost curve. Okay. To simplify our analysis of different market structures, we're going to first impose a flat cost curve, and then we're actually going to make it 0. Okay. And we do that, and in so doing, we normalize the situation. So that what we're really looking at is the difference between price and cost. Notice A and C, A minus C, which is what we've been using. Okay. So we can treat A, which up until now we've been talking about as the vertical intercept of the demand curve, as the difference between the vertical intercept and marginal cost. So we invent this idea of A prime. Okay. Let A prime be this vertical intercept, and let's just let A be the difference between the two. If we solve this situation for monopoly, with A prime being up here, we would get, A prime minus C over 2B is the monopolist quantity. All right, but if we want to just talk about this distance, we can just get rid of the C. And we end up with a simpler formulation. So we take a term out of everything so we can make things a little more simple. This is called normalization. Okay, so with that simplification, we have this picture. This intercept would be A over B. The marginal revenue curve would intercept the quantity axis at A over 2B. Okay. Now if this firm were a participant in a perfectly competitive market and costs were normalized, what would be the regular output? In a perfectly competitive situation, we would have this level of output, right? Where the marginal firm is just barely capturing a profit and the marginal consumer is just barely capturing some surplus as well. So the competitive result is this quantity of A over B and the price of 0, effectively. how do we know that? Well, we would say, okay, in the competitive market, the producers are all going to earn zero profit. And they earn zero profit when they're producing where cost is just equal to price. So we say price is equal to zero. If price is equal to zero and price is equal to A minus BQ, then we set A minus BQ equal to zero. We solve for Q, we get negative BQ equals negative A, Q equals A over B, bingo. So we call A over B the competitive quantity. Similarly, we would call the monopolistic quantity, or the monopoly quantity, would be half of that. So the monopoly quantity would be A over 2B. Or half of whatever it is for the competitive firm. And so we take 1/2 times A over B, we get A over 2B here. Questions? What price would this firm charge? Yeah.
Just twice the price of the perfect competition one?
Okay, the price is zero, so what's 2 times 0?
Nothing.
Okay, so we need a little bit different articulation of it. A over 2 would be the price of the monopolist charges. What would be the monopolist's profit? A over 2 times A over 2B, so A squared over 4B. You see that? The profit to the monopolist would be A over 2, price times quantity, A over 2B equals A squared over 4B. Pretty straightforward. Did you do it this way with algebra and intermediate micro? You had me. Sorry. Sorry. Okay, so we have a baseline. We have a baseline both for competition and a baseline for monopoly. Now we have to think about other circumstances. So we're going to start with duopoly. That means that there's 2 firms. And when we do this, we have to make decisions as analysts. We have to ask, okay, do the firms strategize over quantity or do they strategize over price? In the Cournot model, which we're going to cover today, interestingly, Cournot built this model in the 1830s, which is before the marginal revolution. So before others really had applied the calculus to economics, Cournot kind of was doing it in his analysis of duopoly. So we call him a proto-marginalist. He was doing marginal analysis before the marginal revolution. Other proto-marginalists are those who recognized the importance of marginal analysis in thinking about how people behave. Among them, of course, is Richard Whately, whose name you'll get tired of hearing. Or not. So this model was actually the first formal model of oligopolistic behavior that was developed, and it's probably the most frequently used model for understanding oligopolistic behavior. Nevertheless, there's some flaws to it. It's not perfect. We start with the assumption that there's just 2 firms. Right, we start with an assumption of 0 marginal cost. Now that's not essential for the model, but it simplifies it. So we're going to assume 0 marginal cost for now. We assume perfect information. And we consider homogeneous products. Okay, so perfect info. Zero marginal cost, homogeneous products. What's missing from our list of basic assumptions for perfectly competitive markets? Yes,
Easy entry and exit.
easy entry and exit. And one other one. Large number of sellers. Because we've assumed that there's only two firms, right? So we're relaxing some of the assumptions from our perfect competitive model in order to get some analysis done here. Of what it would be like if we relax some of those assumptions. Okay, so the firm's decision, the behavior of the firm is to select the quantity. When the firm selects its quantity, it's going to take the other firm's behavior as given. So it doesn't imagine that it can affect its rival's output. It figures that the other person's already made its decision. You ever play soccer? You know what a penalty kick is in soccer? You watch Ted Lasso, right? Okay. You know what a penalty kick is in soccer? When the penalty kick happens, both the kicker and the goalie have to kind of already made a decision about what they're going to do. A very good goalie might have a faster reaction time than other goalies. A very, very good goalie can change their mind about which direction they're going to jump to try to block the shot after the kick is done. But usually it happens so fast, the kick is so hard, that the goalie has to decide beforehand which way they're going to go. Maybe the kicker can watch the behavior of the goalie and see and guess well or determine ahead of time which direction the goalie is going to go. But it's not always true, right? So in this case, the kicker has to have in their mind already a decision about what direction the goalie is going to go. And so they're reacting to, right, the behavior of the goalie. In the same way, in the Cournot model, we're talking about a situation where the firm that is trying to decide what quantity to produce has an idea about what it is that the other firm is going to do. And it's taking that idea as a given in making its decision. It doesn't believe that it can affect what the other person is going to do. In the same way, the kicker doesn't believe that the goalie can change which direction the goalie is going to go after he kicks the ball. Okay, so then we have to build this thing. We have not one firm with a quantity anymore. We have two firms. We have firm 1 and firm 2. And together, the total quantity that gets produced is the sum of the two. Okay, so now what we're going to try to figure out is, okay, what will firm 1 do given the behavior of firm 2? How will firm 1 react to firm 2's behavior? We start with some assumptions. So how many will firm 2 produce? We're going to take that as a given. And then firm 1 is going to react to it. If firm 2 were to produce the competitive quantity by itself, right? If firm 2 is already going to produce the competitive quantity, what's the competitive quantity? A over B. All the way out here, right? So if firm 2 is going to produce the competitive quantity A over B, then firm 1 can't find a market. Firm 2 has already produced all that the traffic will bear. So firm 1 can't find a market. So how many would firm 1 produce if it thought that firm 2 was going to produce quantity A over B? None. It would stay out of the market. So the decision about how many to produce is 0. The fewer units that firm 2 produces, the more that firm 1 will be willing to produce. Notice that I don't have price on this axis. This graph is a graph of the quantity that firm 1 produces and the quantity that firm 2 produces. Always double check your axes to make sure you understand what it is you're thinking through.
So then we have a function that is firm one's reaction to firm two. If firm two produced nothing at all, how many would firm one want to produce?
All of it.
Not necessarily all of it. Because if firm two produced none, firm one would be a monopoly. How many units does a monopolist produce? Half as many as a perfectly competitive firm, or the perfectly competitive market output. So then firm one would produce not the same amount, but half of that. The monopoly output. So we get this line here. Noise is effective. We get this line. This is firm one's reaction to the behavior of firm two. So we call it a reaction curve. Some of you are like, I'm having a reaction to it right now. I'm allergic. Can we show it mathematically? Do we have to? Yes. So then we have the quantity for the industry is equal to quantity one plus quantity two. We want to know firm one's profit maximizing output. So one is going to produce A minus B, and we usually put Q here, but we've got two firms, Q1 plus Q2. This is the price. Remember, price is equal to A minus B, Q. So this is the price, and we multiply that by quantity. But in our multiplying of this by quantity, we're going to multiply it by the quantity only produced by firm one. Where did the costs go? Remember, we set them equal to 0. So I can leave off the second half of that equation. Makes the math here a little bit easier. Okay, so let's expand this out. I get A minus BQ1 minus BQ2, all multiplied by Q1. I get A Q1 minus B Q1 squared minus B Q1 Q2. Now what do I want to do? I want to find the profit maximizing quantity, right? That would be first derivative of the profit function of firm one with respect to the quantity produced by firm one. So I'm going to take the first derivative of this with respect to Q1. That would be equal to A minus 2B Q1 minus B Q2. Catch up real quick. And at profit maximizing quantity, all of that would be equal to 0. So what's the last step in our analysis here? Solve for Q1. So I get negative 2BQ1 equals negative A plus BQ2. Moving the A and the BQ2 to the right-hand side. Multiply everything by negative 1. I get 2BQ1 equals BQ2. I'm going to leave it on A minus BQ2. Then I'm going to divide everything by 2B.
And so the quantity that firm one chooses to produce is A over 2B minus 1/2 Q2. So now I have a quantity that firm one is going to produce expressed in terms of the quantity that firm two is going to produce. We have eyes when we're caught up. I'm not even trying. So. You try.
You have the graph next.
So what do you expect the next step to be? We have a reaction function. We have an expression for this line. That's what this is. This is an equation that tells us what this line looks like. It's kind of flipped around because we've got Q1 as the left-hand variable. So the intercept is the intercept along this axis, but then we've got the slope going up towards the other axis. You see it? Okay. That's what firm one is going to want to do. What's firm two going to do? Same thing. They're going to want to do the same thing. And if firm two does the same thing, then we basically could just rewrite this expression for firm two, Q2 equals A over QB minus 1/2 Q1. In other words, firm two has this reaction function. Okay. In equilibrium, what do we expect? We expect each firm to produce at the point of intersection. In equilibrium, we expect the firms to land here. Well, that's not A over 2B, and it's not A over B. How many is that? It's less than A over 2B, isn't it? Can we solve for where that is? Sure. How? How would we solve for that? Well, we would take Q2's reaction function and plug it into Q1's production function or reaction function. So Q1 equals A over 2B minus 1/2 times Q2. But we know that Q2's reaction function is this. So we plug this in, A over 2B minus 1/2 Q1. And now we've got an expression in terms of one quantity. And we can solve for Q1 to find out how many units Q1 will produce. Working this out, Q1 equals A over 2B minus 1/2 times A over 2B plus 1/2 times 1/2 times Q1. I just distributed this negative 1/2 through. A over 2B minus 1/2 A over 2B is what? You can collect terms here, can't you? I think that you have to put 2 in the numerator here. And what you get is A over 4B. Plus
1/4 Q1. Subtract 1/4 from both sides, or 1/4 Q1 from both sides, we get 3/4 Q1 equals A over 4B. I'm sorry that my A's look like 9's and Q's. It's gotta be aggravating. Multiply both sides by 4 and divide both sides by 3. Fours cancel. Q1 is equal to A over 3B. Does that seem interesting to you?
Yeah.
Because this is A over B, this is A over 2B, this would be A over 3B, or in other words, 1/3 of the competitive level of output. So each firm is going to produce 1/3 of the level of competitive output, and there's 2 firms. So what's the total quantity that's going to be produced? 2/3 of the competitive output. So if I put this back on my demand curve, not the reaction function graph, okay? Here I'm going to have the total quantity. Here's the price. This is A. All right. How many will these 2 firms produce in combination? Not the monopolistic quantity, not A over 2B, right? But 2A over 3. And each firm will produce 1A over 3. So firm 1's output is A over 3, firm 2's output is A over 3. So when there's a duopoly, we get 2/3 of the competitive level of output. That redistributes a great deal of the surpluses back to consumers from producers relative to a monopoly. What would the price be? I think you can say intuitively that it would be A over 3. And you can solve for that. This is the key result for a Cournot duopoly. The next step would be to generalize this outcome for a larger number of firms. What if there were 3 firms? What if there were 4 firms? We'll do that next time. Thank you.
Yeah.